Hey everyone, welcome back to my channel, A Monk in Cloud. In this video, we are going to build another exciting project where we are going to see how an event-driven image processing pipeline with AWS Lambda and S3 is built. So this is how the architecture looks like. Basically, this project demonstrates how to build an automated event-driven image processing pipeline using AWS Lambda and S3. Basically, when an image is uploaded to the source S3 bucket, an Lambda function is triggered which processes the uploaded image by pixelating it into 5 different resolutions like 8x8, 16x16, 32x32, 48x48, and 64x64. It uses the library called Pillow, or shortly PIL. So these processed images are then stored in a processed S3 bucket, which you are seeing on the screen right now. So this project leverages a fully serverless architecture, ensuring high scalability and cost effectiveness. And this is what you're going to learn. So you're going to learn how an AWS Lambda event-driven architecture looks like, how to trigger the Lambda function in response to S3 buckets. And you'll also see how image processing with Python Pillow library works, techniques of manipulating images, including pixelations, etc. And you'll also see how to deploy a serverless application with all the libraries that we install. And you might be wondering, like, Yashwant, where are we going to use these pixelated images? And the answer is here. It is going to be used in privacy protection, basically pixelating parts of images such as faces or sensitive areas is often used in media or public content to anonymous individuals. It is also used in creative designs like pixelated images are popular in retro or abstract art, game design, or for styled visual effects. And it is also going to be used in data reduction, so where applications reduces the image resolutions is required for quick previews, or when bandwidth is limited, pixelation can be used to create a smaller image files as well. We will also try to use this in video and image compression. Pixelated previews are useful in scenarios where image or video quality can be progressively enhanced as more data is loaded. And blur detection and machine learning. As you already know, machine learning is booming today, and pixelation can also be used in processing images to test machine learning models on recognizing shapes, patterns, or when reducing visual noise is necessary for certain types of analysis. Now, I have the solution as well, so stick till the very end. I'll make sure to provide all the code along with this GitHub repository in the description box below. So if you are going to build this project along with me, make sure to hit the like button and also subscribe to the channel, and also spread out word in your social media platforms saying that you're building this project, and tag us along with that, right? So first, let's go ahead and get started. And here is the project solution. The stage 1 is to create the S3 bucket. As you saw in the screen, we need 2 S3 buckets. One is the source one, other one is the destination. And we also need a Lambda function, and that's all, right? We also need to write the Python code and along with the libraries. So first, let's go ahead and create the S3 bucket. So I'm going to name this S3 bucket as AMC image pixelator source, AMC image pixelated processed for the processed or the destination S3 bucket. Make sure to use a different name because S3 expect you to create different names for different users because it should be globally unique. So you cannot use a name that I'm using right now. So make sure to change the name in your repository and also in the code where we are going to deploy that. Okay, first let's go ahead and create this bucket. So let me copy this. Let me go into my console, search for S3 and open S3 console in a new tab. So this is my S3 console. Let's go ahead and click on create bucket. And here I'm going to copy or paste the name that I copied and scroll all the way down and click on create bucket. And that's all you have to do for the step 1. Next, let's also do the same thing for the destination bucket. So I'm just going to copy this one. Let's go to S3, create a bucket, give a bucket name. You just copy it, scroll all the way down and click on create bucket. And we also need one more bucket for storing our code. So I'm just going to create a bucket and help you understand what we are doing what we are going to do with that bucket later. Okay. So I'm just going to name this as AMC code hyphen buck. Okay. Buck for bucket. Scroll all the way down and click on create bucket. So make sure to change the name accordingly, right? So this bucket that we just created is used to store our code. Okay. Now, what is the next step? We need to develop the Lambda function code. To do that, we need to create a folder called, so either you can develop the Lambda function on your local machine or in the AWS console directly. So if you are following along with me and if you do not have a good development environment, then I would recommend you to use Cloud Shell in the AWS console to do this. So firstly, it is saying you need to create a folder by the name my Lambda deployment. So let me just copy this. And if you do not know where the Cloud Shell is, go ahead and click on this icon and it will open a Cloud Shell for you. Now it is asking us to create a directory. So I'll say mkdir and paste this one. Okay, now let's go inside that folder. So we are inside this folder called my Lambda deployment. Next, let's see what is the next step. So we also need to create a folder called Lambda. So let me just do that. So I'll say mkdir and I'll say Lambda. And let's go inside that folder, Lambda. Now this step is also done. Now we need to create a file called lambda function.py and paste the code that we have in the Lambda function. So let me just copy this one. I'll show you what we are trying to do. I'll just go inside the console and I'll say, let me clear the screen first so that you won't miss out. I'll just say, I'll use my favorite editor, Nano. Okay. And then I'll paste this lambda function.py. And it will open a Lambda Nano editor for me. Now let's go to the function itself. So this is the Lambda function. So I'm going to open that in the new tab and explain the code first. So firstly, I'm importing all the things that are required. Okay. Next, this is the bucket name that we are going to use. Process bucket. We are going to set that as an environment variable in the Lambda function. So I'm going to show you that as well. And this is the Lambda handler function. Firstly, we are getting the bucket and the object key from the event object. Basically, when an object or an image is uploaded to the source bucket, it will trigger this Lambda function, right? So firstly, we need to get that bucket and the object key details from the event. So that is what we are trying to do here. Next, we are going to generate a temporary name and set a location for that original image that we are trying to upload. Next, we are trying to check if the object exists in the source bucket or not. And if so, we are also going to download the source image from the S3 bucket to the temporary location within the execution environment. And then we are trying to pixelate the images into 5 different pixels, that is 8 by 8, 16 by 16, 32 by 32, 48 by 48, and 64. And then we are going to upload the pixelated versions to the destination bucket. So destination bucket, we are going to set that as an environment variable. And if everything looks good, we are going to send a status code 200 and say successfully processed and uploaded pixelated images. And this is the main function that we are going to use it. So if this looks good to you, so go ahead and copy this file, go into your console, Control V, and click on paste here. And you just have to go with Control X and then say Y and hit enter. That's all. Just to verify, I'll just say cat and I'll say Lambda. And if I'm able to see the same code, then it is good. If you see here, it is the exact same code that we just copy pasted. So I'll clear the screen for you. Let's see what is the next step that we need to do. Once we have this Lambda file created, we are going to download this file. So let me just copy this link address, go inside the console. I'll say wget and I'll paste this URL. So this is going to download all the things required. If you see here, this is downloaded and it says status code 200. Okay. Next, we are going to unzip this file and we are going to remove the file as well. So after using this file, we are going to remove it, right? So the package should only contain the code and the required libraries and nothing else. So we are going to unzip that. So I'm going to run the unzip command. And next, I need to remove the file because I've already downloaded it and I do not need that yet. So let me just copy this, go to my console, clear the screen. Sorry for the typo. Now let's just paste this one. It is going to remove that. Okay. Now we need to zip all these things into a zip file and then upload it to the Lambda function. So let me just copy this. Okay. So just looks good. Let's go inside here and I need to paste this here. If you see here, it is it zipped all the code and all the libraries that are required into a single file. How to see that? So let's clear the screen. Let's go one folder behind and let's say ls-lrt. And if you see here, this is the zip file that we just created. And we need to use this as a bucket or use this as a code in the Lambda function. So how do we do that? So what we can do is, let me just duplicate this tab. Let's go ahead, open the AWS console, close this, and I'll go to Lambda. Let's go ahead and create a function without any further delay. I'll say image pixelator, okay? And I'll choose Python runtime 3.9. This works only with Python 3.9. Make sure to choose that. And we are going to use an existing role. I've given the admin privileges for this one. So go ahead and create the function. One thing that you need to note in the Lambda function, either you can develop the code here itself or upload it from the S3 bucket or from your local machine. So as we had many different libraries that we are working with, we cannot or download and install all the libraries here. So what we are doing is we are just creating the layers, right? So firstly, what we can do is we can upload it from the zip file or from the S3 location. So as we are going with AWS, it is so simple to transfer a file from the console to the S3 location. So what we are going to do is, as you saw, I created a bucket called AMC code buck. So I'm going to transfer that zip file using the AWS CLI commands into this particular S3 bucket. So how do we do that? So let's go inside here. So let me just copy this name, AWS S3 CP for copy, paste the file name, and you need to provide the S3 bucket name, S3:// it is AMC code buck. And that's all. Hit enter and you will see upload is completed. So let's go ahead and verify here. If you see here, there are 0 objects. If I refresh it, you should be seeing a file here, right? So let's just copy the S3 URL. Let's go to the Lambda function. Let's click on Amazon S3, paste the URL that you just copied and click on save. Once you have this, so it is still updating here. You can see it has successfully updated now. Now let's go into the configuration. We need to change this default timeout to 5 minutes. So let's click on edit. I'll just say 5 here and I'll make this as 0. Okay. Now I'll click on save. And remember, you also need to set a environment variable. So how do we do that? In the same place, click on environment variable, click on edit. And here you can see you have a name called processed bucket. So copy that and go inside this environment variable, click on add environment variable. In the key, paste this one and go back into the bucket, select the processed bucket and provide that in the value, then save it. So this completes step 2 as well. And the last thing that we need to do is to add a trigger. Basically, if you go back to the repository, if you see here, this Lambda function is being invoked by the source bucket whenever an object is added, right? So that's what we are going to do. Let's click on add trigger. And here in the source, we need to select S3 and the bucket. Remember to select source S3 bucket and event type. You can keep it, put or all object events. There is nothing that we can do here. And we can acknowledge and click on add. That's all you have to do. And next thing that we need to do is to test this Lambda function if it is working fine or not. So let's go ahead and do that. So let's open both source bucket and the processed bucket side by side. And if you see here in the source bucket, I do not have anything. And in the pixelated processed bucket, I do not have anything. So let's go inside the source bucket. Let's click on upload. Let's go ahead and upload the original image.jpg. And if you do not know what is that file, so let me just open and show it to you, the beautiful cat. So this is the cat with a swag that we're trying to upload it to a S3 bucket. So let's do that. So I'll just click on add and I'll select the original image and open it. Scroll all the way down, click on upload. And if this looks good to you, so let's close this. And if you refresh it, you have one object. Let's go to the image processed pixelator. So I'll just refresh it. And if you see here, you have 5 different files that are created. Okay. And if you see the timings also, it is matching. So now, if you see here 16 by 16, let's open that and see. Okay. Basically, if you open this object URL, it is going to give you the error message. So what we're going to do is let's go back, and instead of clicking and opening it, so let's open this. And if you open this file, if you see here, this is how the pixelated image looks like. And if you see, you can see all the pixels here. And this can be used in machine learning processes and things like that. Right? So the same thing is with other files as well. So if the number is more, if the number is less, that means that it is highly pixelated. And if the number is higher, for example, 64, if you open this file, right? So it looks very similar to the original image. Let's see that as well. Okay. And if you see here, it is similar, but not highly pixelated. Okay. So this can be used in the machine learning processes and things like that. So this is all I have for this particular demonstration. So if you're liking the content that I'm creating, please consider subscribing and share it with your friends. And if you're building this project along with me, make sure to tag us on LinkedIn and also, spread a word that you are building this project. And one more thing I forgot to say, let's say you are facing some issues. Do not just go ahead and comment on the video saying that I'm facing this issue and how do we resolve. Use ChatGPT, use internet, and get to a point where you can troubleshoot all your issues in this project, right? And let's say you want to visualize or you want to understand where exactly it is causing the issue. Go to monitor and here click on view CloudWatch logs. It is going to give you the logs. You can check what is happening in this Lambda function and resolve it. For example, let me open this. And if you see here, there was an event that was triggered. Basically, this was added from this source IP, and I uploaded an image called original image, right? So that was there. And then the request was submitted to the Lambda function, and a request actually consumed so much time and so much memory, right? So this is how you analyze the issue. And if there is an error, it is going to display in the same logs as well. Okay. So make sure to delete everything once it is done. So that is an important thing, because if you keep it running, you're going to be billed, right? So that's all I have for this video. Thank you, and I will see you in the next one.